Actually, let's just talk about them. You guys can help me answer the question. So, the first one that I see there, which one would you choose, Cassie?
Well, I put E.
You put E, which is logarithmic differentiation,
Yeah.
and that was because.
I don't remember. I did this the other day.
So why did she choose E? Which is the correct answer, but so it's not. It doesn't involve logarithms. So really, the first four involve logarithms. If you have something that doesn't involve logarithms but involves a complicated product or quotient or something raised to a power, so what we could do is we could take the natural log of both sides. So the process of logarithmic differentiation is you take the logarithm, and so what you would do in this case is you would rewrite it as to the 1/2 power, so you get 1/2. And then once you took the exponent out, you could break up the product of the three terms, so you'd end up with the natural log of x minus 1 plus the natural log of x minus 2 plus the natural log of x minus 3. So that would be the simplified version. And then you could take the derivative of both sides, and the derivative of the natural log of x minus 1 is just 1 over x minus 1, and the derivative of the natural log of x minus 2 is 1 over x minus 2, and so forth. So it's pretty easy. Okay. So let's see, Asia. So what would you think the next one?
I put A.
Just the chain rule. Yeah. Why couldn't you use the properties of logarithms?
I do not know, but I know it would be easier to say.
Yeah, well, the answer, you're right. I mean, it is A, but some people sometimes think that if you have a squared term in there, you could take that out. But because the squared is not over the entire argument of the natural log, then you can't do it. So if it was, say, if it's 2x plus 1 quantity squared, then you could use the properties of logarithms. But because there's nothing that the whole thing is squared or the whole thing is raised to a power. So you're correct. So you just use the chain rule where you'd have f of u would be the natural log of u, and u of x would be 2x squared plus 1. Okay, so you're right. Okay, who we got now? Savannah. So what did you think there? D, which is using the properties of logarithms, which is correct. So how would we rewrite? Do you know how we would rewrite the original function if we use the properties of logarithms? Yep. Now when I hand the test back, you'll notice that I've taken off for some things that I haven't maybe been as picky about in the past, and I didn't take a whole lot off. I just wanted to at least, if I don't take off, you don't even pay any attention. So for example, in this case, notice I put parentheses here, because if I didn't put the parentheses, it would be just the natural log of x squared and then plus 1. So even though in your mind you know it's that way, you have to be careful. So this one, so what I'm saying is if I just said the natural log of x squared plus 1, you see it as this, but somebody else may see it as, that. Okay, so Hannah, what do you think we should use there? D or? So you're correct. It might be E. And the reason is because it doesn't have a natural logarithm. So if it doesn't have a natural logarithm to start with, then you have to, and it's a complicated, it's a quotient with a square root. So you'd have to use the chain rule with the quotient rule, so it'd be a lot easier to take the natural log of both sides. So what do you think this thing simplifies down to when you, well, let's just take the natural log first. So, and we'd write this to the 1/2 power, of course. Okay, so what do you think? How could we use the properties of logarithms? Yep. Okay, yep, that's right. So the exponent comes out, and so that's the exponent, and then you have a quotient, so you take the natural log of the numerator minus the natural log of the denominator. Okay, so Elias, the next one. D. And so what is the simplified, what is the result after you use the properties of logarithms?
It would be ln of 2x minus ln of x plus 3.
Yeah, notice I guess theoretically I should do this because it could be the natural log of 2 times x, but yes, you're correct. Okay. Xavier, what do you think on the next one?
I put A.
A, okay, which is true. So let's just, what is the derivative? So if the derivative, what you would do is you'd have to use the chain rule. So you would say f of u equals the natural log of u of x equals the natural log of x. So the derivative of the natural log of u is 1 over u, and the derivative of the natural log of x is 1 over x. So f prime of x is 1 over u times 1 over x, which is equal to 1 over the natural log of x times 1 over x. So that would be the derivative of the natural log of the natural log of x. Okay, what do we got next here? Y equals x squared square root of 3x minus 2 divided by x minus 1 squared. Seth. E. And so if you take the natural log of both sides, looks like that. And so how would I rewrite this using the properties of logarithms?
I would probably put the 3x minus 2 in parentheses and raise it to the 2 1/2 power, and then you would the natural log of that minus the natural log of x minus 1 is fine squared.
Yeah, say the first part again.
I would read the square root. I would just rewrite that as
Oh, okay, I see what you're saying. Yep, you're right. So we'll write this as to the half power. Okay, now what do we do?
and then the natural log of the numerator.
Yeah, so you'd have the natural log of x squared times 3x minus 2 to the half power minus the natural log of the denominator. Okay, keep going.
You could bring the exponents to like as a coefficient.
What's that now?
Couldn't you take the exponents put it as a coefficient?
Well, you can't take this out of completely here because this is only to this part. But you could break these two parts. You could break this apart because this is a product.
To addition.
Yeah. So you'd have the natural log of, what's the first part of the product?
The natural log of x squared and then plus the natural log of 1/2 3x minus 2.
And then what's the last thing we could do?
Bring the exponents out as coefficients.
Yeah. That's it. Okay. Evan. A. Yes. Okay. Yeah. So uh, f of u would be equal to, and u of x would be, yep. Okay. That's good enough. We can, let's go. We'll do one more and then I'll hand out the tests. Put you out of your misery. Uh, So Mark. E. Okay, well, almost. It already has a natural log, so you don't have to use. So it's D. Yeah. So use the properties of logarithms. So how would we simplify this thing?
Move the exponent forward, and then you could subtract.
So you take the exponent out like that. And then what's the last thing I can do?
You could do the ln x plus 1 minus ln x minus 1.
Okay. So that's good. Okay, so we remark, so it's Margaret's turn here. So the next one is, seems like we did that one. Didn't we already do this one? That's one Mark did. So let's go to the next one. The natural log of x plus the square root of 4 plus x squared. Okay, Margaret.
Okay. I think it would start with A.
Yes. Yeah.
So U would be x plus the square root of 4 plus x squared.
Yeah, f of u would be the natural log of u. I mean, yeah, we're not going to work it out, but the reason I put it in there is because, it is a fairly complicated argument in the natural log, but there's no properties of logarithms that we can use because we're adding stuff, and the square root is only over part of the expression. Some people may mistakenly do something like this, which is wrong, so don't write it down. They get carried away with properties of logarithms. If it was x times the square root of 4 plus x squared, then you could. But because of the plus sign, you can't do anything like that. Okay. Add a couple pages here. So we got, So we got y equals the square root of x squared minus 1 over x squared plus 1. Okay, Michaela. E. And so let's do that. And what would be the simplified? Okay. Well, we have to deal with this first. Yeah, so you take the 1/2 out, which would just leave us with this whole thing. So the first step would be to put that outside, and then the second step would be what you said. At this point, we'd have to use the chain rule in these because they're not, because it's not just x minus 1 or x plus something, it's x squared. You'd have a little more complicated expression. Okay. Okay. Maya. D. Okay. So what do you think we do? Yeah, so you can break these into two products. There is the intermediate part right here, which you'd have 1/2 I know you'd have it'd be fine leaving this step out, but just for everybody else, first you break it up according to the product, because this is applied just to this part, not to that part, and then you could bring it out, or you can do it all in one shot as long as you do it correctly. Okay, so Crea, what do you think? What's that? D? D. Okay. The problem with D is that you've just got the natural log of t, so there's not anything you can do. I mean, it's already simplified, so that's why I put it in there. So it's just a quotient rule. Okay. Yeah. So this would be, you just have to use the quotient rule because it's already in it. If it's already in its most simplified form, then you just use whatever the appropriate rule is. So it's C, quotient rule. Okay, here we go. Y equals the natural log of the cube root of x minus 1 over x plus 1. Daniel. It's D? Yep. Yep. Yeah, because it's already a natural logarithm, so we don't have to do anything to it. And what is the simplified version? Say the natural log, you're changing it first to a fractional exponent. Yep. Okay. Good. Back to Hannah, I guess. What do you think? E? Yep. I mean, theoretically, you could multiply it out, but in some ways, it'd be easier to do this. Okay, so we're going to take the natural log of both sides. So what's the simplified version of that, Hannah?
Would you have to put the natural log in front of everything and then?
Well, you could break it up. When you have a complicated quotient or product, the ones that are in the numerator are positive, and the ones that are in the denominator have negative signs. So you could just break this up into 4 parts. So what are the 4 parts?
Ln of x plus 1 plus ln of x plus 2 minus ln of x minus 1 minus ln of x minus 2.
Yep. Okay. I think that's it for the different techniques as far as that's concerned. So the next 4 are just using the appropriate technique. So the first one is which method? A, B, C, D, or E? The natural log of x cubed plus 3x squared plus 2x minus. Do you have that on there? Or this one here? Yeah. So which one of those are we going to use? A. Yeah, it's just the chain rule. So go ahead and use the chain rule. By the way, during physics, my supervisor is going to come in and observe the class. So just so you know, he's coming. And don't be your normal rowdy self. No, just kidding. Yeah, no. he came to calculus last year, so he wanted to do physics this year. I think we'll have our physics test Friday after we come back. It'll be on chapters 7 and 8. But today will be our last class on that material. We'll move on to chapter 9 material when we come back. So there's your answer. One thing when we get to chapter, well, it might be even this chapter. If I said, what's the integral of 3x squared plus 6x plus 2 over x cubed plus 3x squared plus 2x minus 1, you might, initially you wouldn't have any idea. We know the answer is the natural log of x cubed plus 3x squared plus 2x minus 1. The thing is, if you change this to a 1, then it doesn't work, right? Any number, if the derivative of this is not exactly equal to that, you can't use the natural logarithm to integrate it. So the question is, how would you take something that's not exactly matched up and make it match up? 1. So section 1 is to do with differentiation. So that's what we covered so far. We've kind of it's due Friday of after we come back. So you've got a whole week. You shouldn't have anything to do or break, right? I don't think there's anything to do. Well, at least from our class, well, you might still do, but shouldn't have that much.